Okay, so I want you to imagine something. You look up, and way, way up there, you see a power plant just floating, silently. It's harnessing winds that are so powerful, so consistent, that they're basically an untouchable resource for us down here. Now, this isn't some sci-fi movie. It's the real story of airborne wind energy. A story, by the way, that's got massive ambition, some pretty big failures, and now an absolutely incredible comeback.
And this quote, this just nails the whole spirit of what we're talking about today. Perhaps we will fail, but if we succeed, the value dwarfs all the potential failures. I mean, talk about high stakes, right? It's a huge bet on this really radical idea. What if the greatest source of clean energy isn't down here with us, but thousands of feet above our heads? Well, this is the story of what it takes to try and reach for that power.
All right, so let's get into it. Our story actually starts in a pretty unexpected place. Not some high-tech lab, but with a kiteboarding enthusiast named Don Montague. This guy had this wild dream to circle the globe on a catamaran pulled by a giant kite. But here's where it gets interesting. He was showing his kitesurfing buddies, who, just happened to be Google founders Larry Page and Sergey Brin, how much crazy power was up there at higher altitudes. And they saw it.
You can see the journey right here. Google poured money into it, and they built this incredible prototype called the M600. I mean, look at this thing. It had the wingspan of a small jet. It could power 300 homes, and it had a bunch of successful test flights. For a while there, it really looked like the future, but then reality hit. After 13 years and just so many hurdles, the project was grounded for good in 2020.
So let's take a closer look at the tech they built, because it was genuinely incredible. The M600 was basically an autonomous energy kite. So here's how it worked. It would start at its ground station, right? And then it would use its own propellers to take off straight up, just like a helicopter. It climbs to about 1,000 feet, and once it's up there, it starts flying in these huge acrobatic circles. As the kite whips through the air, that wind forces its rotors to spin, turning them into mini turbines. So it's generating electricity right there on the kite itself, and all that power gets sent down to the ground through this special tether.
You'd probably think, well, I guess the whole idea was a dead end. But that brings up a really important question. Why were they trying to go so high for wind in the first place? What's the big deal about being 1,000 feet up? Well, let's get into the science, because the reason is incredibly powerful.
The answer, it turns out, is all about a fundamental law of physics. It's about how wind actually behaves the higher you go. See, the air above us isn't just a little bit windier. It is a completely different, exponentially more powerful energy environment. And if we could just tap into that, well, we could unlock one of the greatest clean energy sources on the entire planet.
Okay, and the math behind this is what makes the whole idea just so compelling. It's not a simple linear relationship. It's something called the wind shear power law. And what it says is that the energy in the wind is proportional to the cube of its speed. Now, let that sink in. That means if you double the wind speed, you don't just double the power. No, you increase it 8 times over. It's a total game changer. And it gets even crazier. When you get up to an altitude of, say, 1 mile, the winds are so much stronger and so much steadier that they can generate up to 27 times more energy than the winds we can get with our normal ground-based turbines. Let me say that again. 27 times. That is the prize. That's what everyone is chasing.
So, look, the key takeaway here is that the physics makes perfect sense, right? Even if Google's project couldn't quite crack the economics, the potential is just, it's too massive to ignore. So you have to ask, was that the end of the dream? Nope. Not even close. The idea was about to make a comeback, and this time, it was bigger and way more ambitious than ever before.
Okay, now fast forward with me to early 2026. Picture this. In the skies over Sichuan province in China, something massive and almost unreal appears. This wasn't a kite zipping around in fast circles. This was something totally different, and it signaled a huge comeback for airborne wind energy.
Meet the S2000. It stands for Stratosphere Airborne Wind Energy System. Let's just call it SAWS for short. Now, instead of a fast-moving kite, I want you to think of a massive floating power station. It's basically a giant helium-filled blimp, an aerostat technically, that's as tall as a 13-story building. It just floats up there at a stable altitude of over 6,500 feet, and built right into it are 12 separate wind turbines, all just spinning away silently in those powerful high-altitude winds. And in its first big test flight, the S2000 did a lot more than just float. It actually generated 385 kilowatt hours of electricity. But here's the really big deal.
For the first time in history, for a system this big, it successfully synced up with and fed that power directly into the local grid. I mean, this was a massive milestone, a huge proof of concept.
And this chart really puts the evolution of the whole idea into perspective. I mean, just look at the difference. On one hand, you had Makani's kite, which was super dynamic, acrobatic. They needed constant, complex adjustments to stay in the air. On the other hand, you have the S2000, which is this stable, high-altitude platform. It operates more than twice as high, it's designed for 5 times the power, and it's already shown it can connect to the grid. It's a totally different philosophy, really. They're trading all that high-stress, complex flying for a simpler, probably more durable way to get to the exact same goal.
So, here we are. We've got this incredible new tech that's actually proven it can work. It's a genuine engineering marvel. But what does that actually mean for our energy future? Let's take a step back and weigh the enormous potential against the very real-world hurdles that it still has to get over.
When you lay it all out, the promise is just huge. On the plus side, you're getting access to way stronger, more consistent power. You're using 40% fewer materials because there's no giant steel tower to build, which is a really big deal for both cost and the environment. And it's fast to set up. We're talking hours, which makes it perfect for disaster relief or remote power. But then you've got the challenges, and they are just as significant. You have major safety and airspace issues to solve. I mean, what happens when a big storm rolls in? You got to bring that whole thing down safely. The long-term costs and maintenance are still a big question mark. And here's a critical one. It relies on helium, which is a finite, non-renewable resource with a pretty shaky supply chain.
But you know what? Despite all those challenges, the ambition behind this technology is only growing. They've hit 2,000 meters, but that's not the endgame. The next target is even higher. They're literally reaching for the upper layers of our atmosphere. The ultimate prize? The stratosphere. We're talking about 6 miles up. Up there, the winds can blow 200 times stronger than on the surface. And listen to this quote from the CTO of Sawi's. Once we generate wind energy there, the cost of electricity could drop to 1/10 of its current level. I mean, imagine that, 1/10 of the cost. That would change everything.
So we've gone from a kiteboarder's dream that literally fell back to Earth all the way to a new giant successfully connecting to the grid on the other side of the world. After all these decades of building bigger and bigger turbines right here on the ground, could the real future of wind power actually be found floating